So of course, first thing to getting power in the shop is getting power in the shop. So got to install a meter base. Bonehead me should have checked first. I just assumed my block would need to go here, but I can actually do my first hanger right here. That threw me off because the elevation change, it just hit me. The floor in here is a lot higher than the ground outside. So, you know, 5 foot where the bottom of the meter needs to be is here. When I'm inside, outside, it's actually down here. But anyway, with any electrical, you know, the typical disclaimer, make sure you know what's okay in your area. Some areas let owners pull permits and get inspections and do the work. Some don't require permits, some require a licensed electrician. Just make sure you know that. I am not a licensed electrician. I'm doing what's allowed in my area. If you're uncomfortable with this, find someone who is a licensed electrician to do all your work. Of course, this is not a how-to, just how I'm gonna do it, especially this quick part. Once we get into all the running wires in the shop though, I'm gonna talk through some of my ideas of what I think is gonna make the shop useful from an electrical standpoint, so I don't have to worry about popping breakers all the time and have power where I need it and have the power I need where I need it. All right, meter base is all installed, got the upright. The only thing left is to ground it. Got an 8-foot grounding rod. And to just kind of expedite that process, I'm gonna auger out a hole first. Kind of funny story, Steel is sponsoring some videos and sent me this to do some projects at the old house where I don't live anymore. Fortunately, we can do those here, but I've done so many things with this except those projects yet because we're not quite there, but those projects have changed some. They're gonna be really cool, so stay tuned for those. That really sped that up. How quick and easy that dug. It's hopefully not just an indication of how good that machine is, but that my dirt is soft and I can hammer it in the rest of the way. And these are made in America too, which is pretty sweet. We managed to get the grounding rod all the way down. I have a direct bury connector, so idea is I've already got the panel grounded. I've got a mini trench. I forgot to buy some. I'm going to get some straps to strap this down, but I'm going to leave this exposed, and then after they hook up power and or inspected and hooked up power, then I can just cover all this up. All right, now the meter box is done pending inspection and hookup. Now the reason I went with a box that has some service on the outside, it has a disconnect and then spots for some breakers. I'm not going to use any breakers on this, but this gives me an outside disconnect just for fire safety or anything. If I do need to cut off the whole power to the shop but can't safely get inside, gives a way to do that. But more than that, the interior's not finished yet, spray foam's supposed to go in tomorrow, then I get the walling, then I can hang my panel inside and start doing all the wiring. But I don't want to get all that done, then wait on the power company. So having a disconnect allows me to get power out here, and then once I'm ready to hook up the power, I can safely attach my lines to that with this de-energized, pull it through, and then as soon as I'm ready, flip the switch and have power. Power company have already done what they need to do. We have a bunch of conduit run. We're about to start pulling some wires from the main box, but there's something really important I need to do here first. This is a bonding bar that bonds the ground and the neutral together. It is important that they be bonded, but it's really important that they're only bonded in one place at your service panel, because my meter base also has some breakers and the ground and neutral are bonded out here. This is actually my service panel, and my panel inside technically is a sub panel. Because that's a sub panel, we have to unbond the ground and neutral. It has to do with there being an extra way current can flow. Honestly, my head doesn't totally wrap around it, but just know it's important that your ground and neutral are only bonded in one place. So even though this just jumps right through the wall, hooks to another panel, it's no good to have that bonded. So before we do anything else, we're gonna take that apart. Now our neutral bus and ground bus are separate, so I need to make sure that all my neutrals only go on the neutral, grounds only go on the ground. On the service panel outside, there's actually only one bus because they are grounded and you can mix them up together. Here, if we mixed up ground and neutral, which you see in a lot of old panels, and that's something homeowners and amateurs do sometimes, you can run into ground neutral interference, and that just can start causing a bunch of problems in your electrical system and radios and whatnot. As I mentioned, this is our first main run. We have 4 110 circuits and 2 neutrals because I'm going to use a shared neutral, which is fine, but you have to be really cautious about how you orient your breakers. We'll talk about that when we get there. This is going to supply all the power to the top. I need 2 circuits in order to handle all my lights, because I have about 38-foot lights that are going to pull around 2,500 watts. So that's more than a 20 amp breaker can handle. And then I'm also going to have some breakers outlets up there for some drop cords and 3 air filters. The 3 air filters will all share one circuit because they're 1/3 horsepower motors. And then the 2 drop cords that I'm going to have hanging from the ceiling will also share a circuit because we probably won't use both of them at the same time. And that saves me pulling a circuit. And next time I set up my fish tape again, I'll show you the way I like to set up fish tape that helps make things pull easier. One of the things I had to do, because I only bought 1 roll of black, red, and white, was measure out one of my lengths and cut it so that way I can pull them all at the same time, because once you've already pulled wire through a raceway, it's a lot harder to get your fish back through it depending on how many wires you have. So in as much as possible, I try to make 1 pull if I'm using the tape. It's different if you have really short raceways, like 4 or 6 feet, where you can don't even have to mess with the fish tape and you just fish the wire through. But yeah, let's get ready to do it. All right, you've pulled before. Is this enough lube for the pipe, or do I need more?
More lube is always better.
More lube is better. Okay.
You gotta rub your pipe with the lube. There you go. Get off.
All right, go pull my chain.
Holding the lube on it.
All right, you should be popping out pretty soon. There we go. Last time I pulled conduit was like in high school when I was working on a building up in Kentucky. And then we recently did some out here for the HVAC, but that was flexible. That was a lot tougher. This was my first time using it. That's why I figured I would try the lube. Way easier. Like, that's stupid easier with the lube. Although once we pull that big 8-gauge wires, I hope it's as helpful there, because that's just gonna suck. Pulled my 2 switch circuits and all my switch legs down into 2 gang boxes. I'm gonna have 4 dimmer switches because I'm gonna have 4 zones of lights. You might notice I have 2 reds. I ran out of colors, sue me. One thing that might be noticeably absent to some people is a white wire, no neutral. Switches at least here in America on our 110 Edison system, don't require a neutral, because all you're doing is breaking or connecting the hot circuit to whatever the switch is controlling. So no need for a neutral here. One thing you'll also notice in the whole system is you'll see very, very few ground wires, no green wires, no grounds here. Why not? This is grounded, but because I'm using all EMT and making sure I have all metallic conductors, and my EMT is connected to the main box with metal, this is actually my ground. So I'm using all the conduit as the ground, which is allowed by code. And then where like the lights connect, they'll have a green wire that will screw to the box to ground everything. So that saves one conductor that I have to pull through everything, and yeah, makes things a little simpler. So yeah, time to just hook all this up after I screw these boxes in. Just a few things that I wanted to mention. Oh, and no neutral here. I know some people are probably saying, but if you ever want to add smart switches, you need a neutral. You're right. And I have conduit. So one of the reasons I'm going all EMT and conduit is if I decide I want a neutral, I'll just pop the cover off the box up there, open one of these, and pull a neutral, and I'll have a neutral. It's going to be really easy to expand, modify. If I decide, I want some switches over here, I can just boom, run some wire, or more outlets, whatever I want to do, I can just tie into the system easy. So that's why I like this. One of the nice things about the back-to-back panels is, and having everything labeled, I could pull my lighting circuits out here, throw them on a double pole breaker. I'll get into why that's important later. And I want to keep the inside panel de-energized as long as possible, but I'm live out here, so that way we can have lights while we work, because I'm tired of working in the dark. First, kick it off. Now, let's go see if we did everything right. All right, we should have some lights on the end.
Oh, yeah. Oh, yeah.
That's real bright. That's nice.
Flickering?
No. About to do the last pull and just realized I mentioned I was going to talk about how I like to do pulls, but haven't yet. So it's tempting, and for like really small gauge wires, it's fine to use this hole and just hook your wire through that, tape your other wires to that one wire. But if you're doing very many or thick wires, it's best to run a string, and then I like to just tie a little knot in it, and that knot's kind of low. Actually, we're doing some thick wire. So just really simple knot. We're not going for Boy Scout merit badges here or anything.
We're not going for that?
We're not going for that. We're just making a series of knots that we can hook our wire through. So what we're about to pull is two 8-gauge wires for the 40 amp circuit that's going to go to the 7.5 horse cutter head motor for the planer, and two 10-gauge 220 volt circuits that'll go to the jointer and to the VFD for the drive motor on the planer. So 4 10-gauge wires, 2 8-gauge wires. I only have one roll each of the 10-gauge, so I just measured and estimated a little high on my wire, pulled that out, snipped it, and we'll set up one of those, and then for the 10-gauge pull and the other 10-gauge pull, we'll pull right off the rolls. Any times I've had to do duplicates, that's what I do. Estimate wire, pull it off, cut it, you know, pull the stuff I've already cut, then pull the other off the roll. The reason I don't just cut everything off the roll first is you tend to waste wire because you want to overestimate. Last thing you want to do if you have to cut is cut short and then have to scrap a big piece that may or not fit somewhere. And also they tend to turn into a little bit of a rat's nest. So if you can pull off the roll, it's a lot easier, which is why we've got our little 1/2-inch EMT on the ladder improvised here. If I was doing much more, I would have taken the time to actually build a cart to mount all this to, but this worked for a little bit. We did only pull in a few thousand feet. So especially dealing with thick boys that we're trying to pull, this is going to end up getting cut off, so not a big deal that I'm bending it a lot. Now I've got 2 really tight hooks. Those little knots I made give me a nice little place to catch that wire and hold it. There we go. Okay, now whether you run 1 wire per knot or double up, you know, your circuit and run both depends on the gauge of the wire and the size of the conduit you're pulling. When I was pulling through the 1/2-inch conduit with the 10 gauge, I would put the 10 gauge 1 wire per knot, because what makes the sticking point trying to pull it is where you bend the wire to be able to, you know, get a hook and actually be able to pull it and not worry about your tape slipping or anything like that, whatever alternative method you might be using. But I'm pulling this through 3/4 inch. Since I'm going through 3/4 inch, that 10 gauge doubled up isn't going to be a problem at all. But when I was going through the 1/2 inch, I would double up the 12 gauge, 10 gauge would get pulled individually. 3/4 inch, you know, 8 gauge will get pulled individually, and I'll double up the 10 gauge. And when I pulled some 12 gauge through the 3/4 inch, I actually just pulled, you know, all 3 wires, both ungrounded conductors and the neutral grounded conductor together. And now that we've got everything hooked, do a little taperoo, keep it all snug and tight together, and make sure if we have to, you know, back push the tape at all, that it won't pop out. That'd be bad. Like all of our outlets, this is an AB circuit, so we've got the 2 ungrounded conductors and our neutral, and here's our 2 outlets. Now to expedite things, we went ahead and we've just been calling these pigtails, because normally this little wire that we have set on here is, you call it a pigtail. Because we have 2 outlets and a faceplate, Robbie pre-built 15 of these, which is how many we needed, so that way once we got to this stage, instead of sitting here messing with these, they just all be built, because shoot, it probably took them 5 or 6 hours to get all of them put together for us, and that saves a lot of time. Now, this box isn't a great example. Unfortunately, we've already done all the others, but in a lot of the boxes, we'd have 3 wires in, 3 wires out, because there'd be 2 neutrals, 2 blacks, 2 reds. One of the things that's required to do if you're doing an Edison circuit or a multi-wire branch circuit or a shared neutral, whatever you want to call it, is your 2 neutral wires, because they're shared between the 2 circuits, they have to get tied together. So you can't just run the neutral off both the screws on the outlet and let the outlet be your only connector. They have to be connected separate from the outlet. Since we have to do that anyways, and we went ahead and pigtailed the ungrounded, the hot connectors as well, and they're getting connected in the box. Now, one of the advantages to that is if we have an outlet go bad, just that outlet will go bad, and we don't have to worry about the entire branch from the outlet going bad. So it takes a little bit longer to pigtail everything and connect it that way, but that's the way I like to do it, and then it's a lot easier to, you know, swap things out later if you have something go bad. Got my panel all wired up. Please don't judge the neatness. It's been a long time since I've done a panel, and this is all stranded wire, which is a little finicky. Solid wire is really easy to get nice, tight, clean bends. Anyway, one of the things, since I'm doing the multi-wire branch circuit or Edison circuits, whatever you want to call them, the 2 110 volt circuits on all my outlets that have the shared neutral. So I've got 2 ungrounded connectors, the red, the black, the hots, and 1 shared neutral between them. That's fine and allowed by code, so long as one of the things you have to do is make sure that your breakers are right beside each other and also tied. You can use a double pole breaker, or you can just use a breaker tie. A bunch of these breakers came with my box, so I used them because I had them, and I just put these breaker ties on them, so when you close one, you turn off both, because the last thing you want to do is be working on a circuit that has a shared neutral, where the shared neutral might be carrying current from the other circuit, and then you have a shock hazard where you could inadvertently close that circuit from the neutral because it has a load. Now, there might be a question, if you're not familiar with these, about, well, aren't you overloading the neutral circuit because this 12 gauge wire is only rated for 20 amps, but you have 40 amps hooked to it. That's why your breakers have to be right beside each other. The two lines coming in to my panel are both 110, 120, whatever it fluctuates. And there's two different phases, and those two phases are offset from each other 180 degrees. What I mean by that is on your AC current, it flows in a sine wave. So you have the positive moment and then the negative moment, positive moment, negative moment. And that happens, it cycles back and forth 60 times a second. That's why we have a 60 hertz system. Other places of the world, it's a 50 hertz system. We have 60 hertz happen 60 times a second. So while one branch is going like this, the other branch is actually the complete opposite. So while phase A is at the peak of its positive, phase B is at the peak of its negative, and then they switch and switch and switch. Because of that, that's what the neutral is seeing. And because those two different circuits that are on the neutral are always opposite, they actually cancel each other out so long as you're on opposite phases with that neutral. Where you can get in trouble is if these were both on phase A or phase B, then you are doubling that load. But as is, the only current you would see on the neutral when you're running it would be the difference in the current between the two circuits. If you have a three-phase system, you can actually use a neutral across three because you have three phases that are offset 120 degrees instead of 180 degrees, but that's a whole other type of electrical setup. But for a two-phase system, you can do two. It's based on wire gauges and everything. But yeah, that's why it's fine, and we don't have to worry about overdrawing on the neutral line because they actually cancel each other out so long as they're beside each other. And you can use slim breakers, big breakers, double pole breakers, single pole breakers. Thing is, they have to be beside each other and they need to be tied together. So if they're single pole, make sure you get these little clips. They're like a buck, and then make sure everything is good. Of course, this is not meant to be a how-to video. There's so much more that goes into electrical and sizing things that I'm not getting into and not covering. I mean, there's a reason why people go to trade school and why it takes like 10 years to be a master electrician and why master electricians required to sign off on a lot of things. I'm just trying to throw some tips for people who are in areas that they can do work themselves, or maybe have a deal with an electrician where you might do some of the legwork, then he'll come make sure everything's okay, or if you're tweaking or whatever. Just trying to throw some ideas out there. But if you don't know anything about wiring, you definitely don't want to start trying to wire up a whole shop after watching one YouTube video on wiring a shop. One other thing I know I'm going to get comments about, and normally I leave stuff like this sometimes just to get comments, but I don't want to answer it a million times. Yes, my panel is upside down, but no, there's not an upside down on modern panels. The instructions that come with this say it can be mounted either way. That's why there's knockouts all the way along it. That's why there's service knockouts on both sides. That's why on the mounting holes, they're oriented two different ways. So one will have the keyhole with a small hole on top, another one will have the keyhole with a small hole on bottom. So that way, whichever way you orient this thing, it's fine. The main breaker can be on the top, can be on the bottom, it's all right. I know some of you may be asking, okay, sure, you're spinning this out here and you're doing this yourself, but you keep saying hiring a licensed electrician. Where does your knowledge come from? No, not a licensed electrician. However, I did work for a licensed electrician for a while, and I wired quite a few houses, wired a commercial building, and then when the Army paid me to pretend to be an engineer, we did a lot of training and instruction on multi-wire branch circuits, three-phase systems, power generation, power distribution, because we had to be able to go anywhere in the world, set up a power system if we didn't have one, distribute that power, manage and maintain that power, and be able to inspect that to make sure it was going well as go to power plants and consult with them. So no, not a licensed electrician. I am an amateur. I don't know everything. I do know a little bit, enough to feel confident that I can wire up my single phase shop and be safe for me. We buttoned up the few last things, and I also want to talk about the lighting because it's great. But yeah, as you can see, we're getting everything sorted in the shop now. Sorry, that keeps changing this video. But anyway, I got 8-foot lights from Marina from Amazon. I'll have a link below. They're 9,000 lumens each, 5,000 Kelvin. They look good. They're really stable. As far as I can tell, there's no flicker, which is awesome. I have them on 4 zones, so I can kind of control the lighting. There's 29 of them, at 9,000 lumens each. That comes out to a lot of light. It's really bright in here. It's really nice. Quick summary of the electrical and what it is in the shop so far. I have a 200 amp dedicated service panel on the outside that has some breakers that feed the HVAC, and also put some outlets on the outside pulled off that panel. Comes inside to my 200 amp sub panel, where on my south wall I've got 5 bays of AB circuit outlets, so shared neutral. Everything is shared neutral between 2 circuits on my 110. So I have an A on the left, a B on the right. Here's where the miter station is going to be, which I'm going to replace this miter station. Another AB circuit. This is the only 2 outlets on these circuits, one for the miter saw, one for a shop vac. I'm also going to have my dust collection piped in, but that way I can plug a shop vac up to the miter saw as well, because those ports tend to get clogged. The same conduit running over here continues running to the other corner of the shop, where I have another AB dedicated. These are the only outlets on each of those 110 circuits, as well as the 220 30 amp circuit for the table saw, which I think I mentioned. All my 220 circuits are 10 gauge wire 30 amp breakers, just so that way everything is easy, with the exception of anything that needs to have a larger. Then up here I have my dust collector, which, is one exception off these outlets. One of these circuits also runs over there to power the 110 on the shop vac. Then I have the dedicated 220 line for the dust collector. Continuing around the shop, I have another conduit line that starts at the panel over there, comes up and runs around the front of the building, drops down behind all my dust collection pipe that's about to go up. And then I have a 110 circuit over there, and then 1, 2, 3, another 4 sets of AB 110 outlets. So there's 5 total on this run. I've got the 220 circuit for my Penguin CNC, and I also have a 220 outlet right over there for the bandsaw. I also have this 3/4 inch drop coming from the panel for the jointer and the planer, which the planer has a 7.5 horse motor, which is a 40 amp circuit, and also a VFD for the 3-phase motor on the drive. So on my center line, I actually have a total of 4 110 circuits on 2 neutrals. 2 of the 110 circuits, of course, come down to the switches like I talked about, power all the lights. The other 2 is an AB circuit with a series of outlets. The A circuit runs all of my air cleaners. I have 3 air cleaners. And the B circuit is my 2 drop cords. I have one over here, which is going to be my lumber breakdown area. So whenever we're breaking down lumber or using this flex space, we have a drop cord. And the other drop cord is right over here, right above my assembly table, which is roughly placed, but this is about where it's going to go. So even though we have outlets off the wall, sometimes it's really nice to have overhead that's close, just to keep the floor from getting cluttered and having trip hazards everywhere. And that's the 2 circuits, the other 2 110 circuits in the ceiling. So should never ever pop a breaker in this place, because whatever I'm running is probably always going to be on separate breakers. So should be pretty rare that we actually ever run more than one item off of a circuit at a time. Of course, the electrical isn't quite fully done, but it's going to be a while till I get to the rest. You'll see, I know it's driving you some people nuts that I have some slim line places open. That's going to be gaps when I pull out the little tabs in my cover for this, which I'm going to do very soon. I'll use those with dedicated neutrals for those lines, because they won't be beside each other, so I can't tie them together for the office, and also some stuff that's going on the other side of the shop outside. So when I do the office, I'll fill in those spots and run those. The actual sort of mechanics, hands-on work of doing electrical and bending pipe and pulling wire, hooking up outlets and switches, very simple. The complicating factor, and what I didn't go into super depth to, because I don't want to open myself up to that liability, and it's something you need to spend a lot of time learning, or hire an electrician, or have someone work with you that knows what they're doing, is coming in to do all your load calculations, figuring out how many circuits of what size you need to have, what size wire those require, and then using EMT is more than just laying out pipe and putting as many wires in there as you can. There are actually guidelines, like if you pull one wire, I want to say it can be up to 53 or 50-ish% the fill capacity of EMT. 2 wires is like 30%, but 3 or more wires is like 40%. So you have to do all the calculators based on, you know, how many conductors of what size you're pulling through. If you're doing a self-grounding system like I am, there's a whole lot that goes into making sure you actually have continuity throughout the whole system and checking that continuity. There's a lot more that I didn't get into and don't have time to. Fortunately in this shop, it's pretty close, but if you have an even bigger space, you also sometimes have to start considering voltage drop depending on how far your lines go. So just know that there can be more that goes into this. Don't be as afraid to, you know, learn, but if wiring a whole building definitely should probably not be your first electrical project if you're not familiar with it. My background and experience is I used to work for an electrician. I've wired quite a few houses, wired a commercial building when I played engineer for the Army. Prime power was what we called it, was one of the 5 mission sets we had. So with that, we went over power generation, power distribution, 3-phase systems, all this stuff. So I'm very comfortable doing the work myself. I know what goes into it, what I need to do. I'm trying to share that journey and some of the ideas like the AB circuits, the Edison, you know, shared neutral circuits that I did, and just kind of the layout and thought process, and just the idea of using EMT, having a self-grounding system, and being able to easily come in and modify this because, you know, all my wires aren't buried in the wall. Anyway, that was a mouthful. I hope you learned something, were inspired, or at least entertained, and until next time, make time to make something.
Why did you miss class yesterday?
Why?
No. I didn't miss class. I didn't miss class. Get it?
But I was sick.